After the knowledge of 7 fundamental units, we have to understand about derived units also. Now I'm talking about few derived units which comes frequently in different chapters of physics. Okay, let's talk about them. First one, work. And this is unit. Before the unit, I want to write formula also. Work equal to force into distance. We know about this. Now, what is its unit? Its unit is joule. Now, how it is joule, I want to tell you about the joule also. If work is equal to force into distance, then force is measured in Newton and distance is measured in meter. Newton is expanded form is kg meter per second square into meter. Now this is equal to kg meter square, and second square when it goes up it becomes like this. This way actually Newton meter is joule. That's why it is taken in the name of the scientist joule. So unit of this physical quantity work is joule, but its expanded form, I mean to say what fundamental unit or basic unit involves in it, then we can write this kg meter square second to the power minus 2 this way. Okay, let's talk about another one. Force. Force is equal to mass into acceleration. This is its formula and its unit is Newton, and we know that the force is defined like this. This is a body. If we apply force on it, then the body comes in motion, and this motion is accelerated motion, and the mass is also involved, and force is equal to mass into acceleration. This is the outcome of Newton's second law of motion. That's why its a unit of mass is kilogram and unit of acceleration is meter per second square. That's why its basic unit involved in force are is kg meter per second square. We can write this way, kg meter per second square or second to the power minus 2. Momentum. What is momentum? Momentum is the product of the mass of the body and its velocity. Now, momentum, mass of the body and velocity. Now, how can we write this? If mass is equal, momentum is equal to mass into velocity. Mass is measured in kilogram and velocity is measured in meter per second. That's why its unit is kg meter per second, kg meter per second, and the basic unit involved are kg meter second to the power minus 1. I'm taking all of them in numerator, not in denominator, in basic units involved in it. Now let's talk about power. Power is formula is power equal to work by time. All of we know power equal to work by time, and its unit is watt. In the name of the scientist watt, it is taken as watt. Now let's talk about them, about this watt. Power equal to work by time. Work by time. And work, we know what it is, kg meter square second to the power minus 2, kg meter square second to the power minus 2. Previously we get it, and this second time is unit is second. That's why if this second goes up, then what happens? Kg meter square second to the power minus 3. That's why we can write the basic unit involves are kg meter square. Here it is wrong, meter square kg to the power minus 3. This way. Okay, now in the name of the scientist watt, the unit of power is taken as watt. Now what is velocity? This is very simple. Velocity is equal to distance by time, and distance by time is the unit the same. Distance is measured in meter, time is measured in second. We are using SI system, and if second goes up, meter second to the power minus 1. Now acceleration is equal to what? Acceleration equal to v minus u by t. V is final velocity, U is initial velocity, and this is time taken. And rate of change of velocity is called acceleration, and its unit is meter per second square. And if second square is taken at the in numerator, it can be written like this. Now area is denoted by capital A, and it is equal to length into breadth. Length is measured in meter, breadth is measured in meter. That's why its area is meter square, and this is meter square. Now let's talk about the volume. Volume is formula is length into breadth into height. Okay, now length is measured in meter, breadth in meter, and height is also in meter. That's why its unit is meter cube. And here also MQ. Now density is formula is density equal to mass by volume, and mass is measured in kilogram, volume just now I told you meter cube. That's why the basic unit involved in density are kg meter to the power minus 3 times meter. Okay, pressure equal to force by area. All these formula we are using later in different chapter, respective chapter. That's why we have to know this formula. It comes with definition and units, but before that chapter we have to understand about the basic unit involved in them. That's why we are talking about this. Now force is measured in Newton and area is measured in meter square. Look at this. This force is pressure equal to force by area, and we know that force is measured in Newton and area is measured in meter square according to SI system. Newton per meter square is taken as Pascal in the name of the scientist Pascal. That's why its unit is Pascal. But what basic units are involved in it? Look at this. Now Newton is expanded form is kg meter per second square, and meter square is in denominator, and this is equal to 1 of the meter is cancelled, and that's why kg meter to the power minus 1 and meter second to the power minus. This is what? This is the basic unit involved in what? Pressure. What are they? Kg meter and second to the power minus 2. Okay, now next is pressure. Frequency is denoted by small f. It is 1 by t. T is time period. This is the reciprocal of the time period is frequency. Reciprocal of the time period of the wave is called frequency of that wave. And that's why now time period is time period. It is time. That's why it is measured in second. So its unit is, we can say this way, frequency is equal to 1 upon time period, and time period is second. Inverse second is called hertz. In the name of the scientist Hertz, the unit of frequency is taken as hertz. That's why I'm writing here hertz. Since it is named in the name of the scientist, that's why initial letter is capital. In other also, if it is named in the name of the scientist, the initial letter is capital. Here also. Okay, now hertz, and actually this is nothing but inverse second. Look at this. This is nothing more than inverse second. When second is taken up, then we can write this way. Now next is what? After this frequency, potential difference. Potential difference is V. And now how to write about this? Potential difference is actually the work done by time. And actually work done between this can be understood this way. This is a conductor wire. How much work is done between these 2 points? How much work is done between these 2 points in 1 second time? 1 second time by the flow of 1 ampere current is taken as the potential difference, 1 volt potential difference. That's why it involves many things. What they are, this volt, 1 volt is equal to work done upon time per unit current. I, symbol of current is I. That's why work done, we know the unit of work done, basic unit. What is it? Kg. Here it is, kg meter square second to the power minus 2, and again we have to divide it with time. The time is what? Second, and again it has to be divided by unit of current, that is ampere. And this second, when it goes up, it becomes kg meter square second to the power minus 3 ampere. When it goes up, inverse ampere. This way we can say that its actually potential difference is measured in the name of the scientist volt. That's why this is its unit volt, and it's expanded from what I wrote just now. Here it is, what I wrote just now. It is kg meter square second to the power minus 3 and inverse ampere. Now the last one left, we have taken 13 only. What is this? Resistance. Resistance is equal to voltage by current according to Ohm's law. V equal to IR, R equal to V by I. Now resistance is voltage by current. This is the voltage, and in the name of the scientist it is taken as Ohm, and the symbol for Ohm is this omega. Now this divided by ampere means what? kg meter square second to the power minus 3, and then this a to the power minus 1. Again current is again involved. That's why again ampere is in denominator. That's why a to the power minus 2. This way, what I presented today, there are different derived units. Among them, few are taken here, 13 are taken, and I wrote the formula of each of them, which is used for calculation, and I told you the unit of each of them, and what basic units or fundamental units involved in each of them is also represented. Okay, this much for today.